All right, this guy, he's a fun one. You ready? We're going to have to break this down quite a lot. And it's going to be fun because we're going to have some nested things happening here. But it's like a fun little puzzle, and it actually turns out to be quite nice. So for this one, if you take a look here and we compare all the rows and the columns, again, we want to decide what's the best way to approach this. Which row is the best to use? Which column is best to use? What makes the most sense? And if I'm taking a look at this, I'm looking at it and I'm saying, oh, I think this guy might be our best candidate for the row to use or for a column to use because I only have one value there that is not a 0, which means in my cofactor expansion, I only need to worry about the cofactor expansion for this first position, right? All the other ones are going to be multiplied by 0, right? If we write this out as, so we'd have the determinant of A would be our A11 position times the cofactor 1, 1, A1, 2 position. Oh, nope. Let's try that again. 2, 1, rows first, then columns, times the cofactor of 2, 1, A3, 1, cofactor 3, 1, A4, 1, 1, 2, 3, 4, 5. We have 5, cofactor 4, 1, and A5, 1, cofactor 5, 1. And that all looks like that's a lot, but this is 0, this is 0, this is 0, and this is 0. So all of that goes away, and it turns out that what's left is that we only need to worry about the determinant and the A11 position and the cofactor of 1, 1. So here's what we're going to do. Problem is that the cofactor, to get the determinant for the matrix that's left, well, the matrix left is a 4 by 4 matrix. So here we go. You ready? So to find the determinant of that, so our A11 position, and again, I'm gonna put the sign there. Doesn't really change much in this case. So we'd have 3 times our cofactor of 1, 1. So the cofactor of 1, 1 is a positive times the leftover matrix here and its determinant. So what I'm going to do is I'm going to express this as a determinant for a matrix because, well, I got to keep going. I got to keep breaking this down and doing it again. So 5, 4, -2, 0, -1, 0. So this right here is the cofactor of 1, 1, because even though I haven't figured out what the determinant is, this notation here is saying this is the determinant of A11, right? So that's what that notation is. Now I can keep going because I need to find the determinant of that, which means I'm going to do it again. So now I'm going to take the determinant of this thing, and its determinant is equal to, and this time I'm going to think about which row or column. And again, I don't have to pick the same row and the same column every time I break this down further, but I'm going to go with this same first row again because I got 3 zeros in there, which means, once again, I only have to worry about the A11, the A11, C11 position. So this is the C1, oh goodness. So this is the cofactor of the original matrix. Now I want the cofactor of this smaller matrix. And again, I'm going to need, I know that's a plus. So this is going to give me, if I carry everything down, so I had that 3 from above. I can drop the plus because I don't need it anymore. This time, so now my new position, 1, 1, gives me a 2. And again, I'm going to cross out the 1 row and the 1 column to think about the cofactor. It's a positive because we're talking about that 1, 1 position, and any size matrix is always going to be positive in the sign matrix. And now I want to find the determinant of 1, 5, 0, 2, 4, -1, 0, -2, 0, which I don't know if you're paying attention or not, but this guy is the exact same matrix as we found in the last video. We found its lovely, lovely determinant to be -2, but just in case you weren't paying attention and you weren't sure, and that wasn't the case, we can do this one more time. Well, let's have it. In fact, I'm going to do, instead of going along the bottom, I'm going to do another column expansion this time, and I'm going to column expansion this way. Why not? Just shake things up a bit. So now I have, wait, folks, I'm not great at picking buttons. Buttons are hard. Okay, so now we have the 3 from the original A11 position, the 2 from the second A11 position, and now I'm going to do this time though, I'm going to do what is that? A1, I'm going to do the column expansion along A1, or along the J column, J3. So A13, I need A23 and A33, right? And I need their, oh, not a plus, not a plus. Losing my mind, guys. C13, there we go. C23 and C33. Now, A13, that one's 0. See ya. A33, that guy's 0. See ya. So I only need the A23 position. So A23, that's this guy, who happens to be, if this is plus, this is minus, this is plus, happens to be a negative. So I need to multiply -1 times a negative, right? That's part of my cofactor expansion. And then I'd cross those guys out, and I get a matrix 1, 5, 0, -2. And again, those straight up and down mean find the determinant. But at this point, we are so close, right? So the determinant of this, if we put this all together, we have 3 times 2 times a +1 times -2 times 1 minus 5 times 0. So we have 3 times 2 times 1 times -2 gives me a -12. And we're done. Whew. All right. That was a fun adventure. I hope you enjoyed it. I certainly did. Let's talk about how to make our lives a little easier. Turns out there's this thing called the triangular matrix. Now, a triangular matrix is anything where the entries below the main diagonal are all 0 or above the main diagonal are all 0. So one's an upper, one's a lower. So an example of this might be, and we don't actually care what's happening above the diagonal if they're all 0 below. So like I don't know, 3, 0, 7, 0, 19, -42, 8, 1. I don't know, doesn't matter. That's an example of a triangular matrix, right? So here's my diagonal. You'll see down here, this triangle, all 0s. We can do the same thing with an upper, or so the upper means that there's actually things in the upper, right? So this would be an upper. A lower triangular matrix, we're gonna go with an identity, but a different kind of identity. So we'll put I'm missing a number. 1, 2, 1, 2, 3, 1, 2, 3, 4. Okay. 7, -2, 1, 1, 8, 9. I don't know, whatever. This would be a lower triangular matrix. The fun part about a triangular matrix is the determinant is just the product along the main diagonal. So, for example, the determinant of this guy is equal to 3 times 7 times 19, which I'm not going to do because I'm going to screw that up. That's 21 times 19. That's too many. The determinant of this guy is 1, because 1 times 1 times 1 times 1 is 1. Look at how fast that was. So, yeah, we're going to use this idea to help us out with something. Coming up next.